All right. So because we've eliminated, if you can't change the same base, right? If you can't change them to the same base and it's ln, we've eliminated that part, okay? The only exception to that would be like if it was e to the 2x equals e to the 5, something like that. This, oh, no, that would be the same base. I'm trying to think if there's any exception to that rule where they're not the same base, and you would change them because if you ln, it would cancel out, but it'd have to be on the same, both sides. No, so it's it. So it's something like this where you're going to ln both sides of that equation. Ln of e canceled, I'd get 2x equals, ln of 5, which cancels, I just get 5, divide both sides by 2, and I get x equals 5 over 2. So something like that, you could see e's as long as they're on both sides of the equation. Yeah, I was saying if you ln, the only time you're going to bring in an ln is if you can do it to both sides. Yeah, because these had the same base from the beginning, you can ignore the base and just set them equal to each other, which would be the same for anything with the same base. So if this was 3 to the 2x equals 3 to the 5th, same thing, right? I would just set the exponents equal to each other. If it was, let's say, 3 to the x equals 9, now I would have to change one of them. So this becomes 3 to the x equals 3 to the 2nd, and then I would get x equals 2. So you could see one in which you have to change them to be the same base. So you want to like be comfortable because you're not going to have a calculator, right? So you want to be comfortable with powers of 2. So like what do I raise everything to that's a square? Some of the 3s, I would say probably like up to 5 to the 3rd. So first 1 to the 3rd, 2 to the 3rd, 3 to the 3rd, those kind of things. I would want to be able to recognize them right off the bat. Fractional exponents, so if it said something like 3 to the negative 1, you would want to know that that's 1/3. And then like your 1/2, 1/3, that kind of stuff. So it said 25 to the 1/2, that's the same thing as what? Square root of 25, which is 5. If it said 64 to the 1/3, I would want to know that's the cube root of 64, which is 4. So like you want to know those basic things so that they don't get hung up. I'm not saying that all of them are going to be that basic, but you definitely want to know stuff like that. If you were, then comes like the mental math part. So like if in my equation it says, and I think there's one, that came out of the log stuff. So the same rules apply for logs and ln's because they are both logs. If you only have one on either side of the equal sign, so if I set 1 log on one side. So if I had log of x equals 3, something like that, then I would want to switch it to exponential. So the base on this is 10. 10 comes over and picks up the 3rd. That would be, there's 3 zeros. So 1,000 would equal x. These are also ones you have to check. Remember, you must check the ones that start with log or ln. So I would look at this. I would work I don't even have to like plug it all the way back in and simplify it. I just have to see if when I plug it back in, I'm trying to find log of a negative or 0. And in this case, you're not, so you know you can keep that answer. Mostly that happened with 2 answers, but not always. Sometimes it happens when you just get 1. You just got to pay attention to it. The next one would be if there's more than 1 log, or 1 log on either side. Let's go easier. 1 log or ln on either side of the equal sign. So for these, you're looking at like a log 3x plus 5 equals log 10x. As long as it's the same log on either side of the equal sign, you use the 1-to-1 property. So we can completely ignore the logs, and we would just set 3x plus 5 equal to 10x. Subtract the 3x. 5 equals 7x. Divide both sides by 7. And I'd get x equals 5/7. And now I got to check it. So if I plug this in here, that stays positive, right? Like 3 times a positive fraction plus 5 is going to stay positive, so it's fine. Plug it in here, 5/7 times 10 is also going to stay positive, so that's fine. So I could keep that answer. If it works for one and not the other, you have to cancel it out. Questions on those? All right, then you had ones in which you have multiple logs or ln's on one side, or both sides actually, of the equal sign. And for these, you want to condense. And then either convert to be exponential or use the one-to-one property. So I'll show you an example of each of those. All right, so in this scenario, I have two logs on one side of the equal sign, right? They're the same logs, so they could be logs or they could be ln's. Keep that in mind, but then it would be it would have to be like something like e to the first, something easier like that. So if this is log base 10 and log base 10, and it's a plus, what happens when you condense them? Multiplication. So then this is log base 10. Now I have back to where I was before, where there's only one log on either side of the equal sign. So after you condense, then you go back to those rules. Wait, did I circle the wrong one? No, yeah. It would be one log on one side of the equal sign. And so this one I would want to condense. So convert to exponential. 10 squared would equal 2x. I'd get 100 equals 2x, and x would equal 50. And then I check. Yeah, it's positive, so it's fine. If when I condensed, let's just say it's that. If when I condense, so I did it again, log, actually let's make this minus so we can practice that. If when I condensed, I still had a log on either side of the equal sign, so this would have become log of x over 2 equals log of 5. I have my one-to-one property. I ignore the logs. I'd get x over 2 equals 5, multiply both sides by 2, x would equal 10, and then check it. It's positive, so I know I get to keep it. Yep. No. You can only ignore if there's 1 on either side. Because if you x that out, it becomes x minus 2, right? You got to condense first. You can't eliminate the logs until there's only 1 on either side of the equal sign. So within this process, and you'll see it like when you're doing your review, there's going to be factoring. Like if when I multiplied these two together, I ended up with a factoring statement. You might have to factor, get 2 answers. You got to test both answers. Okay, so if, let's just say I ended up with 2, like 10 and negative 2, when I plug in a negative 2, it wouldn't work. I would have ruled it out. If it's your only answer, there's no solution. If there's 2 answers and one works, one doesn't, obviously you keep the one that works and you get rid of the one that doesn't work. Yeah.
0 is no solution.
0 would be no solution. Yep. So you cannot plug back in 0. If it's just like this. If it said log of x plus 1, now I can keep 0 because it would still be log of 1. Questions on those? Okay, and then came the graphing. So there was 2 types, exponential and log. So exponential wouldn't have the word log in it, and log would, right? So exponential could be like something like f of x equals 1/7 to the x. For these, it's going to ask for domain. It's going to ask for range. It's going to ask for the horizontal asymptote, and it's going to ask for the x-intercept, and then the graph. So for the exponential, we plug in for x. So I would set up a t-chart, and I would plug in even just -1, 0, and 1 would be good because otherwise the numbers are going to be so big they're going to be off your graph. Even if they are, it's fine too. So if I plug in 1/7 to the -1, that's 7. 1/7 to the 0. That's 1. 1/7 to the first, and that's 1/7.
So with this, we should just do negative ones.
Mm-hmm. If by chance, like there's so much of a shift, like there's been a horizontal shift or a vertical shift, depending on log or exponential, in which you don't get a good curve, just maybe you might want to plug in some extra ones, but just make sure you know that it should curve, like know the overall shape of it. So for this, -1/7 is here, 0, 1 is here, and 1 1/7 is here. My exponential functions have a horizontal asymptote at 0 unless there's a vertical shift. So if it's a plus or minus a number at the end, which I'll show you in a second, then it would shift. But this one does not, which means it's y = 0 is my horizontal asymptote.
What's the situation when you're plugging in the line?
That's the log. Yeah. And so I know my graph would get close to without touching that horizontal asymptote, and it would look like this. My domain for exponential is all real numbers because this points left and right. The arrows point both left and right. The range does not go lower than the 0, so it starts at 0, it goes to positive infinity. And the x-intercept, oh, sorry, that should be y-intercept. Y-intercept, you can either get from your graph or you go to the middle point on your t-chart and it's 0, 1. It's the same thing.
Is it always going to be negative infinity, positive infinity?
For domain. Yeah, for exponential. And then it switches for log. Yeah. So let's say we did f of x equals 7 to the x minus 2. It's still exponential. There's still no log there. I'm still going to plug in for x. So I'd get 7 to the -1 minus 2, 7 to the 0 minus 2, and 7 to the first minus 2. This is 1/7 minus 2, or -1 6/7. This is 1 minus 2, or -1, and this is 7 minus 2, which is 5. So -1 and -6/7 is about there. 0, -1 is here. 1, 5 is here. There's my true exponential shape that like rises as you move from left to right. My horizontal asymptote shifted down, and I know this because of the vertical shift. So if there's no plus or minus after your exponential, like next to it, not in the exponent, but next to it, then there's no vertical shift and it's at 0. But if it's after it like this one is, then my horizontal asymptote shifts down because it's -2. So my horizontal asymptote would be y = -2. So here's my horizontal asymptote. And then my points get as close to without touching that asymptote as possible. Oh, I didn't run through. And then it's going to go through those points that I just plotted. So my domain, again, it's exponential. So -infinity to positive infinity. There's no restriction on what I can plug in for x. The range goes where my horizontal asymptote is. So -2 to positive infinity. Horizontal asymptote I've got. And then my y-intercept either comes from the graph or from the center point on my t-chart, 0, -1. Questions on those? Okay, then you had log graphs. So log graphs, we convert to exponential and plug in for y. It's also going to ask you domain. This time domain's restricted. Range is going to be all real numbers on the logs. It's going to ask you for the vertical asymptote, and it's going to ask you for the x-intercept. Actually, let's just start with x. So my parent function of log could have any base on it. It could be 2, 3, 4, 5, 6, 7, 8. If it's not there, remember it's 10, right? It could be any of those things. The first thing I want to do is make sure that log is by itself. So as it is, it's by itself. I change this to y. I convert it to exponential. So 7 picks up the y and equals x. And then I plug in for y. So 7 to the negative 1, 7 to the 0, and 7 to the first. So 1/7, 1, and 7. I would say be careful here. Most people don't forget to plug in for y because it's weird if you don't. But then they go graph it, and their brain immediately reverses the x and the y, and you tend to graph it like the y, or the x is the negative 1 and the y is the 1/7. Like, be careful. This is my x and y coordinate, right? So I want to go 1/7, negative 1. So 1/7 is to the right. Negative 1 would be down here. 1, 0 is here, and 7, 1 is here. Because it's a vertical asymptote, it's based on the horizontal shift. So it's the opposite of the exponential, which means it's based on what's happening inside the parentheses. If you just set whatever's equal to whatever is inside the parentheses, or whatever's not there, because it could just be an x, equal to 0, that's your vertical asymptote. So I know there's a vertical asymptote at 0, at x equals 0. Yeah. Well, I mean, it'll help you get that curve. So then you want to connect your points to make your curve. You want to be careful not to cross through that. That's why I would recommend drawing the asymptote. You don't want to cross through it. Like, people do this. Like, it's wrong. I can't cross through there. Yeah. So my domain is now restricted. My domain is restricted to the asymptote. So I can't go left of it, which means it would be from 0 to positive infinity. My range is all real numbers because, look, my arrows point down, and even though it's up slightly, it will continue to rise. There's no restriction on your range for logs. And then the x-intercept I can either get from my graph or from the middle point on my t-chart, which is 1, 0. Now, the variations on this are if there's something inside the parentheses, so if it was 7x minus 4, let's say, what happens with this? What does that do? It takes my vertical asymptote and it shifts it to the right. So my asymptote is going to be at x equals 4. So all the way over here, 1, 2, 3, 4. When I go to solve it, the 7 picks up the y before it drops off, leaving the x minus 4. And I end up with 7 to the y plus 4 equals x. And now I'm plugging into those coordinate points. So x, y, same thing, negative 1, 0, 1. 7 to the negative 1 plus 4. 7 to the 0 plus 4. 7 to the first plus 4. Should have just brought in a graph. I didn't, but. So this is 4 and 1/7 and negative 1. 5, 0. 11, 1. 6, 7, 8, 9, 10, 11. So my domain shifted to the right because of the horizontal asymptote shifting to the right. So my domain is from 4 to positive infinity. My range is still all real numbers, negative infinity to positive infinity. And my x-intercept, again, either from the graph or the middle point on my t-chart, 5, 0. Sure. Domain on that first one is 0 to positive infinity. Again, variations on log could be if you had f of x equals log base 7 of x plus 1. What's the plus 1 do here? There's no parentheses. So it goes up. So it does not change. My vertical asymptote would still be at 0 because I would set this equal to 0. It's just going to basically take my whole graph and shift. All my points would have been shifted up 1. But that will happen. Like, you'll see the shifted points when you go to plug yours in. The other thing is you have to be careful how you convert it. Before I can have the 7 pick up the y, that 1 has to move to the other side. So I can't convert to exponential until the log's on the side by itself. So I would have to do y minus 1 equals log base 7 of x, and then the 7 picks up that. Oh, and then it's gone. Sorry, I don't need that. So now I'm plugging in there. And if it was negative, I would have to get rid of the negative on the front before I can get it into exponential. So it would be y equals negative log base 7 of x. I would multiply everything by negative 1. And I'd get negative y equals log base 7 of x. The 7 picks up a negative y. It still doesn't affect my vertical asymptote. It'd still be at 0, which means my domain is still at 0. But it basically is going to take and flip that shape so that it comes like this. But again, you'd get that when you plug in your points. You just have to know to make sure you get rid of anything that's at the front or anything that's added or subtracted from the end. You have to move to the other side before you convert it to exponential.
Can you teach us for those?
Yeah. So T-chart for the first, well, let me start here. T-chart for this one would be 7, negative, negative 1, 7, negative 0, 7, negative 1. So this becomes 7 to the first, or 7. This becomes 7 to the 0, or 1. And this becomes 7 to the negative 1, or 1/7. So 7, negative 1 is here. 1, 0 is here. 1/7, 1 is here. There was no horizontal shift, so the asymptote is at 0. And my graph looks like that. Domain, 0 to positive infinity. Range, all real numbers. Vertical asymptote, x equals 0. X-intercept, 1, 0. The one before it. So I plug in negative 1. 7, minus 1, minus 1. 7, 0, minus 1, and 7, 1, minus 1. So I get 7 to the negative 2, which is 1/49. 7 to the negative first, which is 1/7, and 7 to the 0, which is 1. There's still no horizontal shift, so my vertical asymptote is still at 0. 1/49 and negative 1, 1/7, and 0, 1, 1. So these are when it's like really tight in there. You might want to do 2. I might want to keep going and plug in 2 and see what happens. But I know that my curve has to take that shape. So if you wanted to plug in 2, I would get 7, 2 minus 1, which is 7 to the first, which is 7. 2, 7. Oh, I plugged in for y. 2, 7. So it'd be 7, 2. And then my graph would look like that. You don't need the 7, 2 as long as you know what your curve's supposed to look like, as long as you curve it to the side. And then domain, 0, positive infinity, range, all real numbers. Vertical asymptote, x equals 0, and x-intercept, the one where we plugged in 0, so 170.
The horizontal asymptote would be negative 1, right?
The horizontal asymptote,
Positive.
it would be at 0. Wait, what?
So
It's based on what would be inside parentheses, right? So that's by itself. If it was like this, now it's negative 1. But that positive 1 is acting as a vertical shift instead of a horizontal shift. All right, now what were we asking for? Like
number 22 on the right.
like 20. when you look at 20, there's all ln e's, right? So ln of e cancels and just gives you the exponent, minus ln of e cancels, just gives you the exponent, equals ln of e cancels and just gives you the 5. And this would just be 8. So you want to be able to not get hung up on things like that. You could totally condense it, which is what this is. Like you could condense that down because it's a minus. You could have made it division and then simplified it from there. But you can make it even shorter by just canceling through every ln of e. Any other logs that you can simplify, you want to be comfortable doing. So like if I had log of 100, I want to be able to see that and immediately know that's 2, because this would be 10 to what power equals 100, that kind of thing. If it said log of 100 equals of 10, I would want to know that's a half, right? Because you'd have to square root 100 to get to 10. So those kinds of things are going to be built into your equations. You want to make sure you not get stumped on them, okay? Let's do it here. Okay, so log base 2 square root 2x squared equals 3 halves. Okay, there's more than one way to do this, but for me, I know I got to get rid of that square root at some point, so I immediately make it the 1/2. So log base 2 of 2x squared to the 1/2 would equal 3 halves. This 2 is going to come over here and pick up the 3 halves. So I could either distribute the 1/2 first and then do that, or I could convert it. There's only one log, so I know it's got to convert. It's going to pick it up. So 2 to the 3 halves would equal 2x squared to the 1/2. So this gets distributed. Like I said, you could do that up here. I could distribute it here, or I could wait till now. I'd get 2 to the 3 halves equals 2 to the 1/2, and then x. 2 times 1/2 is just x to the first. You with me so far? So now I can either divide both sides by 2 to the 1/2, or I can square everything and get rid of my fractions. I don't even remember how I did it on the paper. I squared everything, which is probably what I would say to do. Because all the denominators would cancel out with the 2, I would square everything. So then this squared becomes 2 to the 3rd. This squared becomes 2, and then x squared, because 1 times 2. Then I get 8 equals 2x squared, divide both sides by 2. X squared equals 4. And when I square root, I got to remember it's plus and minus. So I'd get plus and minus square root 4, which is plus and minus 2. And then there was a log in my original question, so I got to go back and check it. If I plug in positive 2 there, it's fine. If I plug in negative 2, it's actually okay because I'm squaring it this time. So I keep both. You could have also there's lots of different ways to do this. I could have log base 2 of square root of 2x squared. I could have made this 1/2, bumped it to the front, and done 1/2 log base 2 of 2x squared equals 3 halves. I could have multiplied both sides by 2 to get rid of this. Log base, is it log base 2? Yeah, log base 2 of 2x squared equals 3. And then 2 to the 3rd would equal 2 to the x squared. 8 still equals 2 to the x squared. X squared still equals 4, and x equals plus or minus 2. You could even expand it. Like there's so many, all the rules that we've worked with, because from here I could have even expanded log base 2 of 2 plus log base 2 of x squared equals 3. What's log base 2 of 2? 1. Log base 2 of x squared. Subtract this. Then convert it. And then square root it. So all of that would give you the same answer. That's why they're like with logs, there's not always just one way to do it. Any other questions from the review? Yeah. 22. Oh, I think we talked about this last week, but remember these mean different things. Log of x squared on the left-hand side can be expanded. Like I can bump this to the front and make it 2 log of x. But the one on the right, I can't just bump it to the front. This is saying log of x times log of x. There are 2 of them. So you have to do like this one did, which is move them both to one side, and then factor out the log. So if I were to do that, and you could either leave it as log of x times log of x or log of x squared, but I'm going to end up getting them both to the same side. So I get 0 equals log of x squared with on the outside minus 2 log of x. And then you got to take out a log. And I'd get log of x minus 2. And then I split and solve these. So log of x equals 0 would be 10 to what power? Or 10 to 0 equals x, which is 1. And then log of x equals 2, and this is still 10. 10 squared equals x, and that would be 100. So my two answers are 1 and 100, and they would both work. When you, oh, that's not the original. When you plug them back in, you can find log of 1 and you can find log of 100. So it's different because one exponent, like if you look at the original, one exponent is on the x. That's the one you can shift to the front. The other is on the outside, and I can't bump that to the front. I mean, I can, but then I have to expand log of x. Other questions from the review?